All right, this is our first lesson in the new unit on circles. It's this unit is or this section rather. 10.1 is called circles and circumference. And so first, what is a circle? A circle is the set of all points in a plane that are the same distance from a given point called the center. And so this point here would be the center, and I have some determined distance, otherwise known as a radius. All right, and then these are all that radius distance away. Notice when I name the circle, I'm going to write out the word circle, or I'm going to use this little symbol and I name it using its center. And then here it talks about segments, and that's what we'll talk about next. So a radius, or radii, plural of radius is radii. All right, the radii are line segments from the center, all right, to a point on a circle. And so radius here would be CF. That would be a radius. Okay? And so I would write that as CF. Right? However, CE is also a radius right here. And CD is also a radius right there. So any line that goes out from the center to the edge is a radius. Diameter. Diameter is, well, I guess chord. Let's go chord first. Chord is a segment that begins and ends on a circle. And so the first one to me is this one right here. It starts at point A, or ends at point B. All right, that's a chord. It begins and ends on a circle. However, this one right here is also a chord. Right? It starts at D, ends at E. That's also a chord. DE, though, goes through the center. So a chord that goes through the center is a diameter. It's two radii, or it's the whole diameter. And so the diameter is DE, or you could say ED, segment, or in this case, chord. All right, DE is the diameter. And so that is what we're going to have to do here in our first example. Name the circle, all right, and identify a radius, a chord, and diameter. And so the circle itself, how would I name that circle? Well, I would name that circle using its center. And so I would name the circle X. Probably need that to be a better dot in there. Right? Or I could name a radius. Now there's lots of options here. You only have to name one. Right? X to V is a radius. X to T is a radius. X to U. X to Z. Starting to or you can say any of those backwards as well. And so we'll say UX is a radius. Or VX. I don't know. My handwriting is that bad. Both work, though. Both work. A chord. There's lots of options for chord. Well, there's at least a couple options for chord. All right. A chord could be Z to T or R to S. All right. Starts on a circle, ends on a circle. So we'll use RS. You could use either one. And then diameter is the chord that goes through the center or makes up two different radii. And so Z, T, or TZ is the diameter. And so you got to really make sure you understand those vocabulary terms. Right. So the next vocabulary word is the word circumference. Okay. Before we talk about what circumference is, we have to understand this key concept. A radius is half diameter, or the flip of that would be a diameter is twice as long, 2 times as long as a radius. And they explain what pi is here. Pi is the ratio of the circumference divided by the diameter. And then they use, okay, well, if that's the definition of pi, then to solve for circumference, I just would times both sides by a diameter. So that's how they came up with that formula. And then a diameter is just, one diameter is 2 times as long as the radius. So instead of a diameter, I could put 2 radius here. And so either equation works. C equals pi times diameter, or C equals 2 pi r. 2 times pi times radius. This one right here is probably the more common one you would see if you only get one equation. But both work. They're the same, right? Because one diameter is equal to 2 radius. And so we're going to work on both identifying radii and diameters and identifying circumference. And so TU is 14. What is the radius of circle Q? Well, TU is a diameter. It starts at T, goes all the way through U. It's a chord that goes through the center Q. And so TU is 14. And so TU is 14, but TU is a diameter. So I have to divide it in half for the radius. And so the radius is 7. Now, what do you know then? QV. QV is 7. Yep. But so is QU. That's a radius. So is QT. That is a radius. So there's 3 different radii in that picture. You give it a try. If line segment, or in this case, CD, radius CD, is 8.5 meters, what is the diameter of circle C? Hopefully you got that it is 17. 17 meters will be the right answer there for the U try. Love this problem. Traffic circles, also known as roundabouts. Our world needs more of them, and I would love to have that debate in person. All right. They're circular roadways that reflow traffic in one direction around an island. A car enters a traffic circle 18 meters from the center of the island. If the car drives around the circle until it's back at its original position, what is the circumference of the car's path? All right, we got to understand this problem. So this car is just pulling in. It goes all the way around the circle and ends up there. Right? So they want to know the circumference. That's the question mark. The question here they're trying to find is the circumference. They give you, though, a key piece of information that car is, when it starts, that car right there, when it starts, is 18 meters from the center. And so that 18 goes from the center out to the edge. That's a radius. And so if I take it, okay, what am I trying to find? I'm trying to find the circumference. What do I know? I know R equals 18. And so now I'm going to bring out my formula. C equals 2 times pi times R. And I plug R in. And so I get C equals 36 pi meters, which is the right answer. It's the most accurate answer from a math standpoint. And so that is the best answer from a math standpoint. However, if it was talking to somebody like, how far did you drive? I don't tell somebody I drove 36 pi meters. And so take your calculator. Now, use a calculator that actually has the pi button. And so do 36 times pi. Right? And I get 113.097, right? And so we'll round that to the nearest hundredth, which would be 113.09. Well, 7 is going to round up, so I'll go 113.1. It's 0.1 meters. Right? So make sure you know how to write it either as a pi answer or as a decimal answer. You go ahead and give this one a try. The carousel has a circular base with a diameter of 26. Find it in pi and find it in not pi. What is the circumference in pi and in not pi? All right, hopefully in pi that you got that it was 26 pi. units long. Right? Or if you type that into a calculator, that'd be 81. It says nearest hundredth, so 81.68 feet. Last of these kind of examples, find the diameter and a radius of a circle. So they want you to find the diameter and find the radius. If the circumference is 77.8, so what do I know? I know the circumference. What am I trying to find? I'm trying to find the diameter and then the radius. I know C equals pi times diameter. So 77.8 is what C is. And so if I divide by pi, I would get the diameter. And so now I'm going to take a calculator. I'm going to type in 77.8 divided by pi. I get nearest hundredth is 2 decimal places, so 24.76. And then to get the radius, I have to cut that in half. And so I would get the radius is half of that, 12.38. There are some final notes here on circles. None of these are quite as important, but they're all very true and things you have to understand. How do I know if circles are congruent? Much easier than when like we were dealing with triangles. Circles are congruent if the radius is the same. So if this radius is 5 and this radius is 5, or 5, let's say, centimeters and 5 centimeters, then those circles are congruent. All circles are similar. So again, so much easier, all right, than triangles in both these regards. So make sure you know those rules or have them down. This is a vocabulary word that you're going to want to have. Concentric circles. All right. I always think when people say concentric circles, all right, concentric circles to me, it looks like the dartboard. All right. They have the same center, but they're different size circles. So those are concentric. They have an example of it down here as well. Those are concentric. And then circles, these are the only ways circles can intersect. They can only intersect in 2 different ways. They can either have 2 points of intersection, right, or 1 point of intersection, or just they don't intersect. And that is the end of the 10-1 notes.